Click the tab to view solution. Numerical problem. Calculate the volume, mass and number of molecules of hydrogen liberated when 230 grams of sodium reacts with excess of water at STP. Atomic masses of sodium is 23 units, oxygen is 16 units and hydrogen is 1 unit. The balanced equation for the above reaction is. Click the tab to view solution. Let us learn about the types of chemical reactions. Any chemical reaction involves formation and breakage of chemical bonds of the reactants to form the products. There are 4 types of chemical reactions. They are chemical combination. Here 2 or more reactants combine or add to form a single product. Chemical decomposition. Here a single reactant decomposes or splits into 2 or more products. Chemical displacement. In this type of reaction, one of the reactant element displaces another element from its compound reactant and takes its place. Chemical double displacement. Here exchange of positive and negative radicals of 2 reactants take place, causing the formation of the product as a precipitate. Let us learn about each of these types of reactions in detail. We begin with an example of chemical combination reaction. Let us perform an activity to know about the chemical combination reaction. Click each tab to learn more. Take small amount of calcium oxide in a beaker. Now pour water in the beaker. Touch the beaker. Observe the changes. In this activity, we will observe that the beaker will hot during the reaction. Finally, from this activity, we learn that large amount of heat can be released during the reaction between calcium oxide and water. Here, the 2 reactants, calcium oxide in solid state and water in liquid state, combine and produce a compound calcium hydroxide. Such reactions are called combination reactions. Some other examples of chemical combination are shown on screen along with their respective equations. Let us perform an activity to know about the chemical decomposition reaction. Example 1 of chemical decomposition reaction. Click each tab to learn more. Take calcium carbonate or limestone in a boiling test tube. Place a delivery tube with a cork on the tube. Heat the boiling test tube using spirit lamp or burner. Put a matchstick near the open end of the delivery tube. A gas evolves from the boiling tube and passes all along the delivery tube. The gas puts off the burning matchstick at the open end of the delivery tube. A white precipitate is formed at the bottom of the boiling tube. In this reaction, the compound calcium carbonate or limestone decomposes or breaks as a reactant when heated. This is why the reaction is called thermal decomposition reaction and is endothermic in nature. Quicklime or calcium carbonate is the first product which precipitates at the bottom of the boiling tube. The gas coming out of the boiling tube, which puts off the matchstick, is carbon dioxide. Let us learn about another example of chemical decomposition reaction. Example 2 of chemical decomposition reaction. Click each tab to learn more. Take about 0.5 grams of lead nitrate in a boiling test tube. Use a clamp and stand arrangement to hold the boiling test tube. Heat the boiling test tube using a Bunsen burner. A gas evolves from the boiling tube. The color of the gas is brown. A white precipitate is formed at the bottom of the boiling tube. It is lead nitrate. In this reaction, the compound lead nitrate decomposes or breaks as a reactant when heated. This is why the reaction is called thermal decomposition reaction and is endothermic in nature. Lead oxide is the first product which precipitates at the bottom of the boiling tube. The brown color gas coming out of the boiling tube is nitrogen dioxide. It passes through the delivery tube and gets collected in the gas collecting jar. Example 3 of chemical decomposition reaction. Click each tab to learn more. Drill 2 holes at the base of a mug. Insert 2 carbon electrodes into these holes using 2 rubber stoppers. Connect the 2 electrodes to a 6-volt battery. Immerse the electrodes in water by filling the mug with the liquid. Add a few drops of dilute sulfuric acid to water. Invert 2 water-filled test tubes over the carbon electrodes. Switch on the circuit. Gas bubbles appear in both the test tubes. There is a rise in the level of water in both the tubes to different extents. Carefully remove the test tubes completely filled with gases. Bring a burning candle near the mouth of both the tubes to test the gases. The candle continues to burn in the presence of the gas coming from the first tube. The candle puts off by the gas coming from the second test tube. In this reaction, the compound water decomposes or breaks as a reactant on passing electricity. The reaction requires energy in the form of electricity and is endothermic in nature. Hydrogen is the first product which puts off the candle flame. Oxygen is the second product which allows the candle to burn. Let us learn about another example of chemical decomposition reaction. Example 4 of chemical decomposition reaction. Click each tab to learn more. Take silver bromide in a watch glass. Observe its color. Place the watch glass under sunlight for some time. The color of the chemical changes. In this reaction, the compound silver bromide decomposes or breaks as a reactant under sunlight. This reaction requires energy in the form of sunlight. This is why it is called a photochemical reaction. It is endothermic in nature. Silver is the first product in this reaction in the form of grey powder. Bromine is the second product liberated in the form of a gas. Let us perform an activity to know about the chemical displacement reaction. Example 1 of chemical displacement reaction. Click each tab to learn more. Take a conical flask. Tie a balloon to its mouth. Take a small quantity of zinc dust into the flask. Slowly add dilute hydrochloric acid into the flask. Put a cork on the flask. Gas bubbles appear from the solution. The balloon bulges out. Here the element zinc in solid state reacts with the compound dilute hydrochloric acid in aqueous state and gives aqueous zinc chloride and hydrogen gas. The element zinc, being a more active element, displaces hydrogen from its place in hydrogen chloride reactant and forms the product zinc chloride. Hence this reaction is called displacement reaction. Let us learn about another example of chemical displacement reaction. Example 2 of chemical displacement reaction. Click each tab to learn more. Clean 2 iron nails using sandpaper. Take 2 test tubes and mark them as A and B. Take 10 ml of copper sulfate solution in both the test tubes. Tie a nail with a thread and dip it into the solution of test tube A. Keep test tube A undisturbed for 20 minutes. The other nail and the test tube B are for reference. Take the nail out from the test tube A. Compare the color of the iron nails and solutions in the test tubes A and B. The nail taken from the test tube A turns brownish. The color of the copper sulfate solution fades from being blue in color initially. Here, the element iron in solid state reacts with the compound copper sulfate in aqueous state and gives aqueous iron sulfate and solid copper. The element iron, being a more active element, displaces copper from its place in copper sulfate reactant and forms the product iron sulfate. Let us learn about an example of double displacement reaction. Let us perform an activity to know about the chemical double displacement reaction. Example of double displacement. Click each tab to learn more. Take lead nitrate and add it into a test tube filled with 5 ml of distilled water. Take potassium iodide and add it into another test tube with equal amount of distilled water. Mix the solutions of the test tubes. A yellow color insoluble precipitate is formed in the test tube. The precipitate formed here is lead iodide. Here the lead ion of reactant lead nitrate combines with iodide ion of the reactant potassium iodide to form the product lead iodide as a precipitate. The other product formed in potassium nitrate in aqueous state from the remaining reactants. This double exchange of the places in the reactants forms double displacement reaction. Now let us learn about redox reactions. Knowledge check. The chemical reactions involving addition of oxygen and removal of hydrogen are called oxidation reactions. The chemical reactions involving addition of hydrogen and removal of oxygen is called reduction reactions. Interestingly, oxidation and reduction reactions occur at the same time. Hence, such reactions are called redox reactions. Let us learn about redox reactions in detail with an example. Here, let us perform an activity to learn about redox reactions in detail. Example of redox reactions. Click each tab to learn more. Take 1 gram of copper powder in brown color in a china dish. Place the dish on a tripod stand with wire gauze. Heat the copper powder using a Bunsen burner. The color of the copper powder turns black from brown. Here the solid copper powder burns in the presence of oxygen gas in air. The product formed is the black copper oxide. The reactant copper gained oxygen in this reaction. Hence it is oxidation. Take the black copper oxide in a glass tube supported by 2 strands on its both ends. Put corks with a nozzle in them on the 2 ends. Pass hydrogen gas from the nozzle of the first cork and allow the gas to leave from the nozzle of the cork on the other hand. Use a Bunsen burner to heat the black copper oxide powder in the presence of hydrogen gas. The black color of the copper oxide powder changes to brown. Copper oxide gains hydrogen or loses oxygen and turns into copper again. Hence, it is a reduction reaction. In this reaction, copper oxide is said to be reduced and hydrogen is oxidized. Together, the oxidation and reduction reactions form redox reactions. Now, let us learn about some examples of oxidation reaction from our daily life. Oxidation is the process of interaction of oxygen molecules with anything they come in contact. Some of the examples of oxidation from our daily life are browning of cut surfaces of fruits, formation of metal oxide on metals like iron rust, burning of crackers, formation of black coating on silver items, formation of green coating on copper items, formation of metal oxide on the service wire during rainy season. The spoiling of food materials due to oxidation is called rancidity. Food materials containing oil or fat in them smell or taste foul when left uncovered for a long time. Corrosion or oxidation of metals can be prevented by protecting the metal surfaces from moisture and oxygen. Oiling, greasing, painting, galvanizing and chrome plating, and by alloying. Galvanizing is the process of coating the surfaces of iron with zinc and provide protecting from corrosion. Alloying is mixing 2 or more metals, a metal and a non-metal, to obtain the desired properties like strength, hardness and lightness from the obtained substance. Rancidity can be prevented by adding preservatives like vitamin C and vitamin E, adding oxidants and keeping the food in airtight containers. Improve your learning. Read the questions and attempt the answers on your own. You can click answer for your reference.